Still, again, a lot easier. Still, we have steps that needs to be taken to, but really not going to have bug holes. We're not really going to see some of the things that we see inside of concrete with steel. So, generally with steel or metal, we're dealing with SSPC standards, NACE standards, ISO standards, standards that your country may have developed. Here inside the States, we use SSPC and NACE. These are a joint preparation standards through SSPC. They're outlined inside of their book. Here it is. Surface Preparation Standard Book. This is what we generally use for blasting or preparing metal for coatings. We need to use caution when applying over flash rust or rust. It goes back to we're only as good as what we're sticking to. If we have rust present and we coat over it, the rust is still going to be there. We need to specify a profile. I've seen a lot of jobs where they said we're going to come in and we're going to sandblast the steel and we're going to coat it. Well, what type of abrasive blast are you going to use? What type of profile are you going to use? And we speak of a profile. When we say profile, what we're doing by applying a profile is we are increasing the surface area. So I take this metal plate. It's got meal scale on it. It's relatively smooth. And then we take a plate like this aluminum one that has been abrasive blasted on the back side. It has peaks and valleys. If you look at this on a cross-cut section through a microscope, you'll have peaks and valleys. So we increase the surface area for our coating to bond to, as opposed to a slick plate, which we have virtually nothing there for the coating to stick to. So we can apply it, and very little force we can use, and we can remove the coating from this plate if it's not properly prepared. As with this plate, I'm going to get a better bond with this profile. Different ways to determine what profile we have. One of the most used methods is the use of test-tech tape. We'll get into a little bit of inspection because we want to know what profile we have. We can use a surface comparator, and looks like a end of a flashlight with a magnifying glass on it, and it has a assortment of little daisy wheels, attaches to the back side with a magnet, and you just apply that to the surface that's been blasted, and you're visually comparing these different plates as different profile depths. And you have a plate that's been blasted with sand, one that's been blasted with steel grit, maybe one that's been blasted with garnet. So it's all different. So that's just a visual aid. And you compare, I know on some of the, I think the ISO standards, you actually have a plate that you lay down to the surface, and you rub the plate, and then you rub your surface. And you're using that feel to determine the roughness to, say, if it's SA 2.5, SA this, and so that's another way. Here in the States, we generally use test-tech tape to determine our profile. Has anyone used this? Nope. It is a very simple method. There is a ASTM method that goes along with it. Come down here. Here's the NACE version. I might not have I don't have the AST one, but NACE is just a standard recommended practice. It's a field measurement of surface profile of abrasive blast clean steel surfaces using a replica tape. And there is a method that goes down for using it. And this is NACE standard RP 0287. RP 0287. Pass this around. And this actually takes an exact replica of your surface. And it's got a 2 mil thick mylar film. On the back side it has a little layer of an impressionable foam. And what you'll do is you'll take your surface, after it has been blasted, we'll lay our tape down to our surface area. And during tape we use a whizzle stick, if you can find them. It's just a blunt plastic ball up on a stick. You see them at the cocktail bars, side of the drinks a lot. But I don't have one here with me. I've just used the rounded end of my pen, with my pen brought into itself. I can take it, I just want to push that impressionable foam down into my substrate. Because what I'm doing is I'm making an exact reverse replica of my profile. And did y'all remember what I said, how thick my mylar film was? Nope.
No.
Well, if you didn't, on the front of the tape, it tells you to gauge less 2 mils. So this mylar film is 2 mils thick. So I'm going to take my spring-loaded micrometer that I have. Oh, here it is. Disappeared over here. On my spring-loaded micrometer, you'll notice my gauge is set to 8. And what I've done is I've went ahead and I deducted my 2 mil thickness on my piece of mylar. So that when my gauge reads my profile, it's reading correct. If not, if I set it at 0, whatever reading I get, I have to deduct the 2 mils from it. It just makes it easier for quicker visual aid. I'll just go ahead and preset it to read 8, and that subtracts my 2 mil reading. Just take and open up the spring. So here I've got a 2.6 mil profile. And this is reading my highest peak of this area. The thing about that everyone likes about the test deck tape, and it is an exact replica. And what I can take with a Sharpie, a fine point Sharpie pen, I can go in on my inspection form or my daily job report of the area that I'm working in, and I can lay out, I can put the area that this was taken in. If I'm doing a tank, I'm probably going to do plate numbers inside of the floor, the wall. I can put my plate number or my location. I can also put down my reading, 2.6 mil. There's enough room I can also date and also initial. and I would put this in the job file. And I may take several readings. I'm not just going to take one reading. I may take 40 or 50 readings to determine if I have areas that maybe don't fall into specification. So I may take a lot of different readings of these inside of different areas to ensure that I have good, uniform blast profile. If I have areas that doesn't meet the spec, then those areas will be marked and they will have to be re-blasted to obtain that deeper profile. And these, for us inside of the United States, as far as I know, these are submissible in court. If you ever have to go to court, because these is a exact replica of your surface. There's other meters out there that can go and tell you the profile depth, but they're not an exact replica. These are. And I can attach these to my documents and they become a part of my job file.